Exercise 4.4.5 is another one of our warm and fuzzy questions for the exam. The only difference between this and how it'll be on the exam is that on the exam you will have blanks in these spots, so you won't see these probabilities. They'll be blank and you'll need to fill them in, much like it was on the worksheet in class on Tuesday. So we've been given a little bit more help, a little bit of training wheels on this particular question. So first thing I note is that we have the last sentence. That's usually what I look for first in these types of questions. I have told you that we're going to let B equal burned, S is going to be store-bought, and P will be the event that it plays in the car. So these are the three things that I want to be looking out for as I read through the actual question. In your CD collection, 75% of the CDs you have are burned from your car, from your computer, and the rest of the CDs are actually purchased from a store. So this 75%, because you know me, I want to translate this. The only thing in this sentence is burned. We do have and the rest are actually purchased, but that's telling us that those are two complements of one another. That if 75% of my CDs are burned, that means 25% are store-bought. Right? That's the only reason they're telling us this, is basically to tell us you have the two complements. You have the way to split up all the CDs. All right, the CD player in your car is very particular. If there's even a slightest irregularity, the CD won't play. So you have found that the CD player will play 95, so we got our play, 95% of the store-bought CDs. So if a CD is store-bought, the probability it will play is 95%. And then we continue on, but only 20% of the burned CDs. So we're still talking about playing here. Now we're saying that probability of playing drops to 20% if we're dealing with a burned CD. So these are our given probabilities. So as we saw in class when we talked about this and in the last video, the first thing you really want to do in these questions is think about how we're splitting up, in this case, all of the CDs. We have two ways that we could be splitting this up. Or we could be splitting it up into burned and store-bought, or we could be splitting it up into play and not play. What matters is what we were given, and here the marginals we were given about burned and store-bought. So that's where we're going to start our tree. And we know the probability a CD is burned at 75%. A probability of store-bought is 25%. From there, we have two options. Now we can do the two that we talked about. It'll either play in your car or it won't play. And we know for the burned CDs, that probability of playing is really low. It's at 20%, which means more likely 80% of the time it is not going to play. And remember, every single one of these branches are going to be complements of one another. So you can use these to do all of your figuring out everything in this tree. And we also know of the store-bought, 95% play. So that means of the store-bought, 5% do not play. So we now have all the pieces to start making our tree. Now remember, in our tree, as we multiply down these branches, start here, multiply this, we get our and probabilities. I had an old colleague when I was in master's program teaching, actually I was in my PhD program teaching at SDSU. There was a student there who was in his master's who came up with this idea of a way to get students to remember how these probabilities went. And his mnemonic or device was, in the PGA Tour, we avoid trees. So in our tree diagram, the probability should be the P, just a regular probability. Then the next thing you have is the givens, and then the ands, to try to keep us straight on what goes where. All right, so then we multiply these down, we'll get that and probability. So I'm just going to put down what the actual calculations will be as I multiply down each branch of this tree. And then I'll go ahead and type those into my calculator and figure out what those probabilities are. So it looks like we have a 0.15, 0.60, 0.2375, 0.0125. So now you have all four of your AND probabilities. This gives you the opportunity to make a contingency table, to make a Venn diagram, or just work with the AND probabilities as they are. As we've seen in all of the examples that we've done, there are two most common things that I'm going to ask you for next, and those are the two things that I ask you for next in this problem. So those two things are the opposite marginal probability. So in this case, what is the probability a CD will not play in your car? So nothing about whether it's burned or store-bought, just the probability of not playing. And this is the other way we could have split up all our CDs in the beginning instead of burned and store-bought. And you have two ways you can find this. One, you could just look at your AND probabilities. The two that have P complement are the ones you're going to add together. The other thing you can do is you can go ahead and do, you can do what we did today in class and make yourself a little table, right? P and B need to cross each other because that's our first AND, our first joint probability. And we need to put B complement next to P and S next to B. And then we can fill in this entire table with all the different things that we have in those four probabilities. So play and store-bought, that's here. Store-bought and not play, that's here. If we add them together, we get the 25 total that are store-bought. And then we can add the other way as well. Down the columns, finding our total probability of playing as well as not playing. So I could have added those two together and just done it on the fly, or I can use the table, and then it's even easier to just go, okay, play complement, well, that's just right there. Really depends what you want to do, what you feel more comfortable with on the test. And then the second probability, like I said, will always happen on this particular question. What is the probability, given that it doesn't play, that it is store-bought? So that given gives us a clue that we're doing a conditional probability. Our not playing came after the given, so that's the thing we know. We know the CD didn't play. We know that this is our whole that we care about. What's the probability it's store-bought? So you could use your formula here. The conditional formula, you take the and you divide it by the thing you know. Or you could kind of do this intuitively. We said, okay, given that it doesn't play, so we know we're in this category, it's inside of our CD player and it's not playing, what's probability it's store-bought? And we can easily see that there's our part of this whole that we want to be dealing with. So this is just 0.0125 over 0.6125. Which gives us out 0.0204, or just a little over 2% chance that it was a store-bought CD if it's in there and not playing. So I'll go ahead and break this video here, and then I will come back and make another video for the last example.